Hello, today we are going to do the Canadian Computer Computation Test year 2018 senior problems, problem S1, Voronoi villages. Now let's read the problem. In the country of Voronoi, there are n villages located at distinct points on a straight road. Each of these villages will be represented by an integer position along this road. Each village defines its neighborhood as all points along the road which are closer to it than to any other village. A point which is equally close to two distinct villages A and B is in the neighborhood of A and also in the neighborhood of B. Each neighborhood has a size which is the difference between the minimum point in its neighborhood and the maximum point in its neighborhood. So the minimum point is the leftmost point, the maximum point is the rightmost point. The neighborhoods of the leftmost and rightmost villages are defined to be infinite size, where all other neighborhoods are finite in size. As there is no village to the left of the leftmost village, and there is no village to the right of the rightmost village, so the size of them are infinite. And then what we need to do is to determine the smallest size of any of the neighborhoods, and with exactly one digit after the decimal point. Voronoi is a special kind of diagram in computer science where you define a set of points, and then the area for each point is defined as all the locations which are closer to this point than to other points. In this problem, it is simplified so that we have all the points on a straight line, and the size of each village is defined as how many points you have closer to you. Now let's see the input specification. So the first line will contain the number of villages, and that is between 0 and 100. On the next n lines, there will be one integer per line, where the ith line contains the integer vi, the position of the ith village, and the scope of this integer is between -1 billion to +1 billion. It's still in the range of a 32-bit integer. All villages are at distinct positions, so there are no duplicate numbers from the input. And output specification, output the smallest neighborhood size with exactly one digit after the decimal point. So here we can use the integer type. For the size, we have to use a float or double. As we know, the scope of the position is between -1 billion and +1 billion, so we can't use float, we have to use double as a type. And then let's see the sample. So here we have 5 points defined, and these are the 5 points. And now you can see that the points are not ordered. So once we read the input, we need to sort the numbers before we do the calculation. And the output is 3.0, and there's some explanation for how the calculation is done. So here we have after all the positions sorted, we have 0, 4, 10, 15, and 16, and we know the size of the village at point 0 is infinite, so we don't consider this one. And then for the village at point 4, the size to the left side is here, and this is 2, and the size to the right side is here, and the size is 3. So the total size of point 4 is 5. Don't forget the 1 digit after the decimal point. And then for village at point 10, the size to the left is same as 3, and to the right the size is 2.5. So the total size for village 10 is 5.5. And then let's calculate the size for the village at point 15. The left side is 2.5, and to the right side is 0.5. So the total size of village 15 is 3.0. And then for the village at point 16, and there is no other villages to the right, so its size is infinite, and we don't need to consider it. And then compare the size of village 4, village 10, and village 15. We know that the smallest size is 3.0. So that's how we should do the calculation and solve the problem. And now we have the problem text understood and analyzed. Now let's see how we solve the problem in code. If you have any comments or questions, please leave it down below.